Okay, jump will not store the PC, but call will store the PC. That's why we are avoiding call here. Okay, fine. Call instruction is having the syntax of storing the program counter. Jump is not having the syntax of storing the program counter. Because of that reason, jump is preferable. Okay. Right. Any doubt, please ask happily. Aditya, what you can't understand, please ask me. I can help you. What is your doubt? In all cases where we accept this interrupt, remaining all cases, wherever you need to come back, you should use call only. Only interrupt saves the program counter, not every time it stores the program counter. I am not using, Aditya, please listen carefully. When you say jump, program counter will not be stored. Please listen carefully. When I say jump, program counter will not be stored. Program counter is the value when your processor is at a particular location. PC will have some value. Okay. So jump will not store program counter, but call will store program counter. Call will always store the program counter into the stack. So whether what it is, so here when it is at PC1, interrupt occurs, so it's stored. Similarly, when it is at PC2, call occurs. When it is at PC2, call has occurred. When call occurs, that address will be always stored in the stack. That is the job of call. That is the difference between call and jump. Jump will not store the program counter. Call will store the program counter. Tell me, Aditya, what is your doubt now? Yeah, it is. It can be ISS1 or it can be ISS1 next location. Okay, it depends on the design. It will be generally next location. Next location after this call instruction is PC2. Good. So let's move. Why condition is required here? When interrupt occurs, you should serve the job. That's why you came now. What is the condition required here? Abhinay, you need not check any condition. Na? If masking occurs, system will not respond. System has responded, then only you get to ISS1. Okay, done. Let's move. So that is the whole interrupt structure. So next a small part, serial IO controller. Forget about it, Sura. Right now we discussed that anyway in the programming. Don't worry. Conditional means like if condition. If something is true, do it. Not true, don't do it. Jump only some condition is satisfied. Unconditional means unconditional love. No condition is required. When you say jump, blindly go there. This will again comes into your programming discussion again. I didn't understand, Shivam. PC store data in stack. PC value will be stored in stack. No, while is also having condition. While a condition is true, it will do. Yeah, program counter address will be stored into memory. Yeah, if you discuss after instruction set, you can understand betterly. This is so if you feel difficulty, don't worry, just leave it. Not while one also one condition. Okay, it is checking whether it is one or not. Na? Go to is an example of unconditional. Go to X. Like your Rama is an example of unconditional. You go to forest, you don't ask why I should go. Directly he will go. That is unconditional. Okay. If you say I will go if you come, then it is conditional. So the next part is a serial IO controller. It will take the interface for serial communication between serial IO and processor. That is for taking care of the serial communication SID SOD data. This serial IO controller will be helpful. So now 1 minute. What we have discussed now. This part is done. This part is done. This part, this part, this part. Everything is done. Only one fellow is left for us. What is that? Timing and control unit. Let's see this timing. Let's have this timing and control. Okay. Sorry. Let's start. Why this page came to last? Next, let's see. Here some theoretical part comes. Let's finish it a little faster. So let me explain from the figure first. Okay, see here. Who kept my name? Who is that Shankar? He dedicated his name for me. Right. Good. As if it means bad joke. It means he don't like that joke. He's saying that please don't joke like that. Okay. So let's go. Where is that? So this is the timing and control unit. In this timing and control unit, please listen here. Let me explain one by one all the pins. Then we discuss one by one again briefly. So these two will take care of your power supply, 5 volts and ground. X1, X2 here. What we connect is the crystal oscillator. Here we connect the crystal oscillator and to generate the clock. Internally, it will be divided by 2 by some kind of flip-flop circuitry. Generally, if it is a 3 megahertz, we connect here 6 megahertz. Okay. To monitor this clock, whether the generated clock is proper or not, some distortion is there, all you can check with the help of this signal. This signal can be used to check the clock input, which is that is the clock generated, which is used in the internal circuit. Humko clock is very important. Yes or no? To synchronize your total system, clock is important. That clock is generated by your crystal oscillator connected between X1 and X2. Okay. What is 2-port? There is no 2-port networks here. Yeah, oscillator requires two, na? Do you have plus and minus or not? Is there any way you can generate oscillator from one single pin? It is generating here. Please understand, it is the circuit which is generating here. Okay. Okay. Let's listen here. Listen here. Okay. We generally use crystal oscillator so that what we can, it will generate stable oscillations. Then ready signal. What is this ready signal? Listen, very simple. I am speaking very fast, like ready, read, write, like that I am speaking, but you are not able to receive it. I am speaking in 2x, but you are receiving in 1x. What is the disadvantage? Data will be lost. Then you are not ready, correct? So what I will do is, every time I ask you whether it is clear or not, you will say yes, clear, sir. Then I will move to the next. Same for the system also. System will communicate with the different kind of peripherals. Some may be slower than the system. System may be sending the data fast, but the other device may not be able to receive it fastly. Then system will ask ready or not. Here, if ready is there, it will send, it will continue. If ready is 0, it will wait. Okay. So ready signal is used to communicate with slower peripheral. Is it okay? Are you clear? Are you ready now? Good. Good. Right. So Sushil, any doubt? Okay. So when system is communicating with the slower peripheral, the external device will tell. External device will give whether it is ready to accept or not. Who will tell clear or not? You people. Same way, external device will tell whether it is ready or not. If it is ready, system will communicate. If it is not ready, system will wait. Okay. Now you are ready. Yes, Asif. Here we connect 6. It is divided by 3. By actually, I assume the reason behind that is some flip-flop kind of circuit will be used to divide that into two parts. It will generate both positive and negative clocks. Okay, good. So now the next one is read bar, write bar. These are the control signals used for memory read and memory write, IO read, IO write operations. Active low signals. Bar is there, na? Active low. Next, address latch enable. I already told you what is the use of address latch enable. To enable the latch during address, then disable it during the data operations. This will tell you the status of the computer, whether the computer is doing memory read, memory write, IO read. What is the job done by computer is done by can be explained with the help of S1 S0. I will explain it again, don't worry. Then IO by ember. This signal will tell you whether it is IO operation or memory operation. Hold and hold acknowledge are used for DMA. DMA means what? Direct memory access. What is this direct memory access, sir? I will explain. Next. Then what is that? Reset in bar. Please listen. When you reset in bar is active low signal. When it is 0 for 3 clock pulses, then system will understand it need to reset the system. It will make everything, means program counter with all zeros, start the system fresh. It will give you reset out. Reset out is used to reset the external devices. 1 minute. This is briefly. Now we discuss little more, little in depth also. One by one. Not becomes 0, it is undefined surah. That I will tell you now. I'm just loading all the slides, then I can explain one by one everything so that we can save little more time. Right. So let's discuss this timing and control unit. You people are ready? So it will generate the necessary control signals to execute the instruction in synchronism with clock. Every job should be in synchronism with clock. So the next. Also. When I already told this, nothing more to discuss here. Clock out is used to monitor the clock to give clock to the external circuits also. Reset in bar signal is 0. Chance noise has occurred. Yes, very good. It should not respond. So it should take minimum 3 clock pulses. You should press for some time. You see this in your regular systems also. Long press, it will reset. Okay. Similarly, he also want how much time? 3 clocks. Then it will understand it is a original reset only, not because of some noise or not due to some error. Right? Yes, in your phone also. Then microprocessor will reset. That is all buses. Here what happens is all buses are tri-stated. What is the meaning of tri-state? High impedance. High impedance or open circuited. Registers will be undefined. Okay, it is not 0, it is not defined. What will be its value? Okay. And all interrupts except trap will be disabled. Once you reset it, all interrupts will be disabled with the help of one flag called interrupt enable flag. And your serial output data pin will become 0 and the program counter loaded with 0, 0, 0, 0. What you can understand from this 0, 0, 0, 0? What is the interference you can get from that? Inference you can get? Please tell me what you can understand from that 0, 0, 0.